Distance off second bearing, practice problem 3. We're going to keep going. Let's get into it. Distance off second bearing, practice problem 3. First thing we do is record all of the information given in that problem so we have it. The problem reads, you're steaming on course 215 degrees at 14 knots. There's the first two pieces of information. It gave us our course, which was equal to 215 degrees true. 215 degrees true. And it gave us a speed. And our speed was 14 knots, which means 14 nautical miles per hour. And it says, at 1841, you observe a lighthouse bearing 178 degrees true. It gave us our first time and our first bearing. Time 1 equals 18 hours and 41 minutes. 18 hours and 41 minutes. Bearing 1 is equal to 178 degrees true. 1780 degrees true. And it goes on. At 1904, the same lighthouse bears 156 degrees true. It gave us our second time. Time 2, 1904, 19 hours, 4 minutes. The same lighthouse bears 156 degrees true. It gave us bearing 2. 156 degrees true. And it says, what is your distance off at the second bearing? That's the question. It says, what's your distance off at the second bearing? What is that? That's what it wants to know. And the way we find this is with a table in Bowditch. And in order to use that table, we need the difference between course and bearing 1 and course and bearing 2. So we're going to find those differences. We say the change between the course and bearing 1 equals the course minus bearing 1. So the course, 215. 215 degrees minus bearing 1, 178. 178 degrees. What's that? We'll get our calculator. On clear. 215, 215 minus 178. 178 equals 37 degrees. 37 degrees. That is the change between our course and bearing 1. Now we need to do it for bearing 2. What is the change between your course and bearing 2? You can find that with course minus bearing 2. The course, 215, 215 degrees. The bearing 2, 156, 156 degrees. Put that in the calculator. 215 minus 156 equals 59 degrees. 59 degrees. Whether it's negative or positive, it doesn't matter. We're just looking for this absolute value. Equals the change between course and bearing 2. Now we have these two pieces of information. We can go to our table. Yeah, so come on and check this table out. So the top row here is our bearing 1. We're at 37. Now, interestingly, look, there's no 37 here. So we're right between 36 and 38. And now we need to slide down to this number, 59. That's here on the side. There's no 59. See that? There's 58. So we have to interpolate this. So 37 and 59. What we do, we take these two numbers, 1.57, 1.45. And then we come over here to this column and we take 1.8 and 1.64. we're going to record those on the board, add them together, and divide them by 4 to get the average. We're interpolating this information. We're adding to this table something that's not there. So let's record those. Here we go. 1.57 plus 1.45 plus 1.80 plus 1.64. We're going to add all those together and then divide them by 4. And that'll give us the average of all of them, which is what we're looking for. Those together, divide by 4. What does that equal? That's going to equal our table value. So 1.57 plus 1.45 plus 1.8 plus 1.64 equals, divided by 4 equals, again, 3 decimal places. So 1.615. It equals 1.615. That's our table value. And then we multiply our table value by the distance we traveled between bearings to get the distance off second. So table value 1.615 times distance equals the distance off the second bearing. Now, how do we get distance? Distance is equal to speed times time. We have our speed, 14. But what about our time? We need to get our time. We can use time 1 minus time 2. So we can say the change in time between the bearings equals time 2 minus time 1. Time 2, 19 hours and 4 minutes. 19 hours and 4 minutes. I say it like that to help keep it straight. Time 1, 1841. 18 hours, 41 minutes. Okay, it's going to be hard to take 4 out of 41, right? So we have to borrow 60 minutes. So this turns into an 8. This 0 then turns into a 6. And now our 4 minus 1 is 3. 6 minus 4 is 2. And now it's 18 and 18, 0. 23 minutes. We can't put minutes into this equation. It has to be hours. So we convert 23 minutes to hours. So 23 minutes, and you're going to divide by 60 minutes. So there's 1 hour and 60 minutes. The minutes cancel off. You're left with hours. What's that equal? 23 divided by 60 equals, we're going to 3 decimal places, 0.383. 0.383 hours. That's our time. So now we have a time and a speed. We can get a distance. Our distance equals speed, 14 nautical miles per hour, times our time, 0.383 hours, equals our distance. 14 times 0.383 equals 5.362. 5.362 nautical miles. That's our distance. Now look, we have our distance. We go table value times distance to get distance off second bearing. So 1.615 times the distance, 5.362 1.362 nautical miles equals distance off second bearing. We're almost there. 1.615 times 5.362 equals 8.65963. We'll round to one decimal place here at the answer. So 8.7. 8.7 nautical miles off of the second bearing. Once in a while, these problems are going to come off like 0.1 off or so. But if you rounded the 3 decimal places, you're going to get real close. So let's see what we got. This is problem 3. Ooh, looks like we might have it. 3 is B, 8.7. And now let's double check the answers. That's correct. 3 is B. All right, that's the answer to distance off second bearing, practice problem 3. We have 2 more to do, and then you got 2 to do on your own. We'll see you in the next one.